Hello everyone, myself Faith, and today we will be solving Biweekly contest 183, question number 2. So, let us try to read this question. Like you are given an integer array nums and an integer k. Okay, now in one operation, we can increase or decrease any element by one. Okay, now we have to like they have defined an array is called modulo alternating if there exist two distinct integer x and y such that for every even indices, num of I percentage k is equals to x, and similarly nums of I percentage k is equals to y. Okay, now we have to return the minimum number of operations required to make num modulo alternating. Okay, so now let us try to understand this question through an example. So let us take this example. Okay, so we have given num is equals to 1428. So 1428, and here we have given k equals to 3. So now we have to define x and y, and both should be distinct such that nums of I percentage k is equals to x, and similarly nums of I percentage k equals to y for even and odd index respectively. Okay, so for an example, if I take x equals to 1 and y equals to 2, so now it should be something like this: nums of I percentage k equals to x is 1. Okay, so and nums of I percentage k equals to 2 because y equals to 2. Now, like we have to make sure to find a minimum number of operation to make all the even indices percentage k equals to 1 and all the odd indices percentage k equals to 2. So let us what we are going to do is, firstly we will increment this. Okay, we will increment this first index element by 1. So what we will get? See what we will get. We will get 1, 5, 2, 8. Okay, now at the same position we will, like, at the same time we will increment, like, decrement this 2 by 1. So what we will get? 1, 5, 1, 8. Okay, so now let us try to perform this operation. Okay, so this is the even index. Let us write this index: 1, 0, 1, 2, 3. Okay, so this is the even index. So 1 percentage 3, because k equals to 3, that would be 1. Okay, this is also even index. So 1 percentage 3 equals to 1. This is odd index. So 5 percentage 3 equals to 2. And we are like we took the y equals to 2 and x equals to 1. Okay, and at the last 8, so 8 percentage 3 equals to 2. This also we got 2. So this both odd indices are equals to 2, and this both even indices are all equals to 1, and we required two operations. So firstly we incremented this and decremented this. Okay, so we required two operations, so output would be 2, because this is the minimum number of operations that we took to make sure both the even indices are equal to x and odd indices are equals to y, such that both are distinct, because we have given that both x and y should be distinct. See, both integers should be distinct, they cannot be same. Okay, so at first it might sound difficult, how we are going to solve this problem, but the catch is we can solve it using brute force. So what we are going to do is, we will try to take each and every pair of x and y. Let's say if k is equals to 3, then we will try to calculate the operations for 0, comma 0, 1, comma 1, 2, comma 2, 0, comma 1, 1, comma 0, and 2, comma 1, 1, comma 2. So we will try to calculate for each and every pair. Okay, we will try to calculate the total number of operations that requires to make sure x, and see here we cannot take 0, comma 0 because x and y both are distinct. Okay, so we cannot take 1, comma 1 as well because both should be distinct, and we cannot take 2, 2, comma 2 because both should be distinct. X and y should be distinct. Okay, so we will take this pairs only. Okay, so now we will try to calculate the number of operations where x is equals to 0 and y is equals to 1. Okay, similarly, so let's say for this number of operations would be 3. Hypothetically, let's say, imagine that number of operations to make sure all the x, even element x should be 0 and odd elements 1 should be 3. Okay, let's say for this it should be 5. For this it should be 7. Let's say for this it should be 1. Okay, so now we will make sure to take this x and this y such that we will get minimum number of operations to 1. So we will try to we will be using brute force approach. So we will try to calculate for each and every pair, and we will be outputting the minimum operation, from all of this, the minimum operation that required. So we will take that x and that y. Okay, so what we are going to do is, we will take a minimum variable, and initially we will make it to int max. Okay, int max. Okay, and now we will form a loop, start a loop from int I. Wait a minute. Int I equals to 0 to k, because now we have to calculate it from 0 to less than k. Okay, so this would be give us all the x. Okay, now inside it we will start one more loop from j equals to 0 to k. Now this will calculate for all the y, this will calculate for all the x, and this will calculate for all the y's. Okay, so we will get each and every pair of x and y, and after that here we will be initializing a sum variable which would be equals to 0. So for every pair it will calculate the number of operations that we need. Okay, now inside it we will also increment one more, start one more loop which would start from int k equals to 0, or let's say p, because k is already we have took the k. So let's say p equals to 0 to n, the size of the array. Okay, so we will iterate to the entire length of the array. Now firstly we will try to get a remainder which we have asked, like nums of I percentage k. So we will try to calculate that. So nums of I percentage k. Okay. After that, what we are going to do is, if, okay, let's say if P, which if it is an even indices, okay. If it is an even index, then we will do something else. Like if it is an odd index, then we will do something. So here, what we are gonna do is, we will, let's say, at first we have to x equals to 0 and j equals to 0. Okay, so we cannot take both the elements as equal, because that there should be a distinct integer. So what we are going to do is, we will initialize the if condition. Let's say if I is equals to j, then we will be continuing it. So we won't take this both like this pair. Okay, we will continue. So we will break out of this loop for this particular I and j. Okay, now if the element are, if the index is even, then we will try to calculate it, the minimum number of operations that is required. So int cal equals to absolute value. Okay, absolute of this remaining RAM minus I. Okay, so let's say if we got RAM equals to 2, okay, and K is equals to 3. For one condition, RAM is equals to 2 and K equals to 3. So this will give us, and let's say I equals to 0, let's say, okay. So RAM is equals to 2. So cal would also be 2, because RAM minus I would be 2. Now, we have to calculate, we have to add it, we will be adding it to the sum variable, because we need minimum number of operations. So what we are going to do is, we will take the minimum, let me just write it, minimum of this cal comma k minus cal. Why I'm doing this? Because see, here cal is equals to 2, but for this position, what we are going to do is, we will increment one more, we will add one more to it. So it will become 3. So this and this would become to 0, which we needed. Okay. So instead of reducing it to, we will be incrementing it by 1. So it will take k minus 3 would give us 1, and this would give us 2. So we want to take the minimum number of operations. So this is 1. So we will take this and we will be adding it to the sum variable. Okay. And the same thing we are going to do it for the odd numbers. Just the difference would be, if it is odd, then we will calculate cal into cal equals to abs of RAM minus j. Okay, and then we will be adding it to the sum, similar to the way that we did here. Minimum of cal comma k minus cal. So now we got the minimum, all the operations that are required, all the total number of operations that would be taken when we took a x and y, one x and one particular y. Okay, now we got this. So now at the end we took one minimum, we initialized one minimum variable. Okay, so now we will try to calculate the minimum of this mini comma summy. So this will give us the minimum number of operations that is required from all the pairs that we took. Okay, and at the end we will return mini, which will give us the minimum number of operation by choosing a particular x and y such that both are distinct. So now let us try to see the code of this problem. See, firstly I initialized n, which took the size of the array, then I initialize the minimum variable which is equals to int max at first. Now if k is equals to 1, which basically means it will divide all the entire array. Okay, it will always divide and make it equals to 0. So we will return it as 0. Okay, after that, this initial we started the loop for x, we started this loop for y, initialize the sum variable equals to 0, and if I is equals to j, which basically means both x and y are equal and we don't want that, so we will continue, so we will break out of this loop. And if it's not the case, like if it is not that case, both the elements are distinct, then we will started one more loop which starts from 0 to n, and take the modulus of it. And after that, if it is even, then for even indices we calculated that stuff, and if it is odd, then for odd indices we calculated that stuff. And at the end, we are taking the minimum number of operations from all the pairs that we took. Okay, and return the minimum. So this was the core of this problem. So let us try to run this. See, it got accepted. Let us submit it. See, it got accepted. So this was the question 2 of biweekly contest 183. Thank you.